We have created NTP client configuration and saved it in ntp.conf file. Now we will restart the daemon to make it read the new configuration. The NTPD daemon is usually located in a user sbin folder, but you must use the service command to start, stop, or restart the daemon. The service command actually calls the system5 initialization scripts located under etc init.d folder. Depending on your Linux distribution, either you can use the service command or you can use the initialization scripts directly from the etc init.d folder. But the recommended way is to use the service command. Now, depending on your Linux distribution and the version of NTP available on it, the name of the NTP daemon could change. So if on your Linux distribution NTP version 3 is installed, then the daemon would actually be named xntp or xntpd. If your Linux distribution is implementing version 4 of NTP, then the name of the daemon could be NTP or NTPD, which you can easily find out using the various command which I have shown above. So now I'm going to go ahead and check the status of the daemon first using both the service command as well as the initialization script directly for the demonstration purpose. So I'm going to say service ntpd status, which will show that the daemon is running on my computer right now, and I can also do init etc init.d ntpd status, which gives a similar output. So I will go ahead and restart the daemon, and then I will quickly query the time synchronization status of the daemon using the ntp query tool and grab the output in a file so that we can interpret it. Okay, so let us restart the daemon now. So once the daemon restarts, I will go ahead and query the daemon and store the output in one of the files. Let us go ahead and watch the output till we get all the fields properly populated so that we can go ahead and interpret all of them. Sorry, I need to use the watch command. I have used the watch command, which will show the difference in output every second. I have specifically mentioned the time in seconds which the watch command should watch for the change in output and display it to us. So yes, now I think we have all the outputs populated. Okay, so we can see now that the two time servers that we had mentioned in the ntp.conf file are showing up here as 0.asia.pool.ntp and 0.europe.pool.ntp. So let us now go ahead and interpret each of the fields in this table. So the first field here is showing some characters like a plus sign, and there is an asterisk sign, and there is a blank sign as well. So this first field is what is called as telecodes. So a telecode of asterisk means that our computer is syncing to this remote machine. NTPD daemon has selected the time server in Europe pool as a reliable time source and is syncing to it. A plus sign indicates that the time server in the remote field is a potential candidate for syncing in case our primary time reference dies or is discarded by the NTP daemon due to some reason. Then there is a blank telecode against the local clock, which means no state. So a no state could be because the remote computer is not communicating or because the client has yet not received any response from the remote computer, and so it is not going to show any state there. Or in case of a local clock, it is going to be blank, or it is going to be blank if the remote computer is at a high stratum, which means it is at a stratum greater than 15, which indicates a stratum greater than 15, say a stratum 16. As specifically stratum 16 indicates an unsynchronized clock, and the NTP daemon will never sync to an unsynchronized clock. So in that case, it will show a blank telecode. Apart from these telecodes which are being displayed right now, you can find a telecode of minus sign, which means that particular remote time server has been discarded by the daemon because the quality of the time is not good. Then there could be a telecode of X, which indicates that again that the remote server has been discarded because NTP daemon has found out that because it is distributing a bad time. So NTP daemon has a number of algorithms using that, which it can using those algorithms and also comparing the time with other NTP servers, it can find out whether that particular remote server is a false sticker. That is one of the reason why we need to give at least 3 or more remote time server IP addresses in our configuration file so that NTP can choose the best time source. After the telecodes, we have the remote field, which shows either host name or IP address of the remote computer. After the remote field, we have RFID field, which means reference ID. So RFID field indicates the time source to which our remote machine is synced to. So our remote machine is a time server, and that also is going to be synced to some other time source. So the IP address of the other time source is shown in the reference ID field. So the reference ID field could have IP address. So here the pool.ntp.org time server is a stratum 2 computer. It is a stratum 2 computer. This ST field here indicates it shows the stratum of our time source, and it shows that it is a stratum 2 computer. So a stratum 2 computer is going to take time from a stratum 1 computer. So the IP address of the stratum 1 computer from which the pool.ntp.org is taking time is shown in the RFID field. Apart from IP address, the RFID field can have a string which says local. So a local string indicates that the remote computer is actually a local clock. As you can see here, that the remote computer is. Another value that RFID field can have is .pps, which stands for pulse per second. So the time server in under the Europe pool project shows RFID of PPS. So this the ST here, the ST field indicates the stratum of our remote time server. So the time server in Europe is a Stratum 1 computer, which means it is directly connected to an atomic clock or to a GPS receiver or to a radio clock. So this PPS stands for say a GPS receiver that is receiving a signal, a pulse per second signal, probably maybe from a satellite or from any other source. And so a Stratum 1 time server is the obviously the first choice for the daemon to synchronize, and hence the daemon is synchronizing with that particular time server. Apart from PPS, there are a large number of values that RFID field could have, which could be explored further from the NTP website, www.ntp.org website. I'm going to go ahead and list and explain two of the important RFID values which you are supposed to encounter during your NTP configuration. So first such value is init, which means initialization, and second such value is step, which means step increment. So when you restart the NTP daemon for the first time, then during that time usually during that time these two RFID values come up. So a client takes time to synchronize with the remote computer. If the time difference between client and server is greater than 100 seconds, that is 17 minutes, then the daemon will exit with an error log. So if the time on client is 17 minutes ahead or back from the is more than 17 minutes ahead or back from the time on the server, then the daemon will not even try to sync the time on client. It will immediately exit with an error log. In such case, do a manual time set. So you need to manually set the time on the client to be within the value of 100 seconds so that the NTP daemon could go ahead and synchronize the time. Now if the time difference between client and server is less than 100 seconds but is greater than 128 seconds, so the time difference is less than 17 minutes but is greater than 128 seconds, in that case the daemon will apply step increments to the client, which means that the daemon is going to increment the time on the client in small steps. So during that duration, when the step increment is taking place, RFID value of step is displayed under the RFID field. So now let us go ahead and understand the remaining fields in the NTP query output. So the next field after REFID field is ST, which is stratum. So ST field stands for stratum. It shows the stratum number of our remote time server. So the ST field for pool.ntp.org is at stratum 2, and the time server to which our computer is synchronizing is a stratum 1 server. The next field is T, which shows connection type. So connection types could be U, U, which means unicast connection, L, which stands for a local clock. There could be B, which stands for broadcast communication, and an M for multicast communication. The field after T is a when field. It indicates when was the last time client received a response from the server. This is in seconds. The next field is the poll field, which gives polling interval in seconds. So this field gives the polling interval, the time after which the daemon will go and send a query to the server for time. So right now in our configuration, the poll interval is being shown as 16 seconds for all the 3 time servers, and the poll interval is 64 seconds for the local clock. So now if you remember, while creating the ntp.conf file, we mentioned the options mean poll and max poll. So we gave the command server and 0.pool.ntp.org, and we gave mean poll is equal to 4 and max poll is equal to 4. So this poll field and the mean poll and max poll field are expressed in terms of power of 2. So 2 to the power of 4 gives us a value of 16 seconds. And so the poll field for our 3 time servers is showing a value of 16 seconds. Minimum poll interval is 64 seconds. So a value of 6, 2 to the power of 6 is the default minimum polling interval. The default max poll interval is around 37 hours. So a value of 17 is the maximum poll interval that you can have. It would be 2 to the power 17. The default max poll value is 1024 seconds. So the value in the power in the form of power of 2, it's going to be 10. And the daemon through the configuration file allows us to change the minimum and maximum poll interval value. So through the configuration file, you can have a minimum poll interval of 16 seconds and a maximum poll interval of 37 hours, which is power 17, and this is going to be 4. So maximum poll interval is 2 to the power 17 seconds, which comes out to something around 37 or 36 hours. So that is the poll interval field, after which we have the reach field. The reach field shows status of last 8 polls, that the status of last 8 polls. So a reach field is actually a 8-bit left shift register, and so there are 8 bits in this left shift register, and each bit shows the status of the last poll. Starting from the right hand side, the first bit shows the status of the most current pole, and the leftmost bit shows the status of the oldest pole. So for success is indicated by setting the bit to 1, and failure is indicated by setting the bit to 0. So let us go ahead and take an example and try to understand this field. And this field, the value in this field is actually displayed not in decimal or hexadecimal, but it is displayed in octal format. So say the NTP daemon has just started and no polls have been carried out. So if and when the first poll is successful, one bit is pushed in from the right end, and remaining bits are shifted to the left. Now when the second poll is successful, one more bit is pushed in. Similarly, for each successful polls, one bit will be pushed in from the right end, and the remaining bits will be pushed further to the left. Now these values are displayed in octal format. So when the last 8 polls are successful, all the bits are going to be 1. So when this value displayed in octal format turns out that for all 0 it is going to be a 0 value. For one success, or for the most current poll success, it is going to be 1. For if last 2 polls have been successful, the value is going to be 3. Last 3 polls are successful, the value is going to be 7. And last 4 polls are successful, the value is going to be 17. When last 5 polls are successful, the value is going to be 37. And when all the last 8 polls are successful, we are going to have a value of 377. For we are going to have a value of 77 for if last 5 polls are successful, and a value of 177 when last 7 polls are successful. This example that we have created here, let us go and see if it matches with the output. And yeah, we can see that we can see the reach value of 177, 77, 177 and 3. So this 3 indicates that last 2 polls have been successful, and a value of 77 indicates that last 6 polls have been successful. So so this completes our interpretation of the when, poll and reach field. But a little bit more information is remaining, which I would like to share with you regarding these 3 fields. So it will be easier to understand if we take up an example. So these 3 fields are somewhat related to each other. So when, poll and reach. So when we started the NTP daemon for the first time, the when field was 0, the poll field was 16, and the reach field, all the bits were 0 because there were no polls carried out since we had just started the daemon. Now the when field increments every second by 1, so it became 1, 2, and ultimately it gets to 16. So when the when field becomes equal to the poll field, the NTPD daemon will go and query the remote time server. Depending on whether the query is successful, if the daemon receives a response back from the server from the remote server, and the remote server says that yes, I am also synchronized to some other time source, that query is considered to be successful, and in that case a bit the one bit is pushed into the reach field from the right and the remaining bits are shifted to the left. And when the query is successful, the when field gets reset back to 0, and again it will start counting till 16. When it becomes equal to the poll value, the daemon will go and query the time server. If the daemon gets a response back and the time server says that yes, I am also synchronized to some other time source, the reach field gets incremented, or a one bit is pushed into the reach field from the right and remaining bits are shifted left, and the when field is again reset to 0, and so this process goes on. In case when the query is not successful, when the daemon does not get a response back from the server, or it gets a response back from the server but it does not understand or get the information that the remote time server is also synchronized to some other source, that query is considered to fail, and in that case a 0 will be pushed in to the reach field from the left. So the when field becomes 16, the poll is 16, but the query is not successful, and so a 0 is pushed in from the right and remaining bits are shifted to the left, and the when field does not get reset to 0. It will keep on incrementing. It will keep on incrementing, and another poll interval of 16 seconds, a poll will be made, and depending on success or failure, further actions will be carried out. So that is how from the when field we can actually find out when was the last time a successful poll was carried out, because if a poll is not successful, the when field keeps on incrementing and it shows us time in seconds when was the last successful poll carried out. So having considered these three fields with an example, let us understand the remaining three fields: delay, offset and jitter. They are all in milliseconds. Delay is the round trip time between the client and the server. Offset is the time difference between the client and the server. It indicates how far is the client's clock from the time on the server. And jitter is second derivative of the time samples, or the offset, or say the offset. Yes. So jitter actually shows us how much the offset, each individual offset differs. So multiple time samples are taken and offset is calculated, and how much each of that offset from those time sample differs is the value of jitter. So this concludes our interpretation